Hi, I'm going to show you how to get started in Swift. Now, let me preface this by saying I am not an expert in Swift, and hardly anybody is an expert in Swift at this point because Swift was just announced yesterday at Apple's developer conference, and they just released documentation in the form of an ebook on how to write Swift. I found that Swift came very easily to me, and I believe that it will come very easily to you as well. So what you need in order to get started with Swift is you need to just download the latest Xcode version, which is currently in beta. So I've gone ahead and done that. And you do need to have a developer license in order to do this. And when you open it up, you'll see Get Started with a Playground, and you can just click that. And you can just let it use the default My Playground. Now, because this is in beta, you will have some issues, and I even had my computer crash at one point, but that's why it's in beta. When you first get onto this, you'll see that it has a comment here, which looks like a typical comment of most other programming languages like JavaScript. And then you see an import statement here, and then you see some sort of what looks like a variable definition right below. So we're going to delete all of this. Now, we can keep the import Cocoa in. I found that I do not need it. Everything still runs with it. So I'm going to take it out, and we'll just see what happens. So to declare a variable in Swift, you just simply assign something to it, just like this. So you can say var string is equal to hello world. And you'll see what happens over here is that it prints out that line. So what it's actually doing is it's evaluating the string here. And if you just write string here, like that, it will print it out. So you'll notice that you don't need to create a class, you don't need to do any initialization, or if you're in C, you don't need to create a main file or anything like that. You can just start writing. Very similar to JavaScript or, dare I say, ActionScript. You'll see that there's a lot of similarities between a lot of different programming languages. It's kind of mixing a lot of different programming languages together. Now, as you can see, there's no explicit type declared. This is because type inference will notice that the variable string str is being assigned a string, and the compiler will infer that str is of type string. So you can also declare a type explicitly using the type annotation like this. So you can do var string var. Now, the way that people seem to be doing this is to be using camel case, not underscores. And then you can just type string, and you'll get code completion, which is really nice. Something. Now you can put a semicolon at the end of the line. You also don't have to. And you can more often not do it than do it. Like you can leave it out and it's okay. So the colon that you see there can be read as of type. So this code would read string var or str var of type string equals something. Okay, it's rare that you need the type annotations in practice, and if you provide an initial value for the variable, it should be okay. This is because the Swift compiler will be able to infer the type, as we talked about earlier. If, however, you are declaring a variable before defining it, it might be useful to declare it ahead of time. So consider this. Let's see, var some message is of type string. Now at this point, the compiler knows that some message will be a string even before it's been assigned. So if we try and assign a value other than a string, it will show an error. So we can do, down here we can say some message, and you can press enter to code complete, of course. Hello. And that will work. But if we were to do some message here and we were to say equals 15, you'll see that we get an error, and the error is it cannot convert the expression's type to a string, and the expression's type is currently an integer. So Now let's talk about let versus var. Up to this point, we've declared all of our names of our variables using var. Swift, however, makes one use of another type of a variable declaration with the keyword let. So I'm going to delete everything here. That's L-E-T, let. At its most basic, let indicates that something is constant, and var indicates that something is variable. So if we just look at some code here, we'll create a new constant, named some constant, that will be of unchanging value. You can't change it. So if we write some constant, and we write I am forever constant. So this means that some constant can no longer be modified. You can't change it. So if I do something like this, it's going to throw an error. If we do some constant equals, let's modify it. If we do that, then it's going to throw an error. Cannot assign to let values some constant. It's just not going to let you do it. So let me give you an example, because it's important to note that while the location of the memory, the location of the object in memory is constant, the values within that memory can be modified because it's just that object. Let me show you an example with a familiar object that you would use in an iPhone application, the dreaded NSDate formatter. So you do have to import this let formatter equal NSDate formatter. So now we can actually say formatter.locale is equal to nslocale dot current. Help if I could spell. nslocale dot, stop changing it. It's changing it on me. Dot, there we go. Current locale. And you can also say formatter dot date format is equal to mmdd YYYY. You'll notice that I can set the properties of this object without modifying the formatter name. If I try to modify the address of formatter, I will run into problems. And when I say address, I'm talking about where it's located in memory. For example, let me show you something that will not work. So if I say new var new formatter is equal to NSDate formatter, and I do this, formatter equals new formatter, then we're going to have a problem here because I'm trying to reassign formatter, which up here was assigned as a constant. Cannot assign let value formatter. If the same name will be assigned to different values, you should declare it as a variable using var. And when we were reading the documentation, Apple says, if a stored value in your code is not going to change, always declare it as a constant with the let keyword. The variable are only used for storing values that need to be able to be changed. So we briefly talked about loops. Let's get into that a little bit more. I'm going to highlight everything and delete it. Here's a typical loop. And when I say typical, I just mean here's a loop. So you can say for index in the range of 1 to 5. And when you do that, if you were to just print ln, what is the index each time, we don't need semicolons, then you would get 1, 2, 3, 4. And to prove this to you, I'm going to open up the console. And here's a dumb way to do this. This is going to log h. And we just click this plus button over here. And now we can see the console over there, 1 through 4. So 1, 2, 3, 4. That's when you have a range of 1 dot dot 5. Now, if you want to include 5, all you have to do is you have to do 1 dot 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 5, and you'll get 1, 2, 3, 4, 5. So that's called inclusive. So one thing to note, which I didn't mention before, is that your variable and constant names can contain any Unicode characters when naming variables and constants. You can include anything. There can be simplified Chinese, you can have Hebrew, whatever you want. There's even some really crazy Unicode characters with like dog faces and cat faces. You can even use those. So you can only imagine when people start using those cat faces to name their variables and what open source projects may start to look like in that situation. One other really cool thing is that with these loops is you can use an underscore when you're saying basically, I don't need that index. Now, what this index is doing when you have it there is it's basically creating a constant on every loop. And that's an actual constant, and it's reevaluating that and recreating that on every loop. But if you don't need that constant available in the scope of the loop, you can just put an underscore there, which is not the same as the Unicode character. You could just write hi, and that would just console log hi 5 times because we have 3 dots and not 4 in this range up here. If we were to do a quick little experiment here, we're going to create a constant called base. It's going to be equal to 3. We're going to create another constant. It's called power. It's going to be equal to 10. And we're going to create a variable called answer. That's going to be equal to 1. So in this loop, we're going to say for underscore, meaning we don't need to set a variable each time. And we're going to loop through 1 to the power, which is 10. So this should be 10 times. And then in here, we're going to take answer and we're going to multiply it times itself, multiply equals. So answer is equal to answer times the base. And the base is 3. So what that's going to do is that's going to loop through it 10 times. And then at the end, if we just log the answer, you'll see that we get 59048. Now what's really cool is if we click this plus button next to the answer, we know that it looped 10 times, so we can actually see a graph of that actual increase in value. So I'm going to delete everything. Now of course we have the typical loop that you see when you first learn programming, which is for I equals 0. I is less than 10, and then you can do plus plus I or I plus plus, and then you just have the curly braces on the end, and then you have I. And what you have to do is you have to declare that variable in the beginning, or you have to declare it in the loop. So we're going to do an int. That's got to be a capital I, and you just want to make sure that you have a space between your i's less than 10. Once you do that, you should get this. So then you have I here, and you can of course graph that, and you'll see if we get rid of this graph, we can get rid of all these extra ones. You'll see I is incrementing up from 0 to 10, and we can even do a print line to see what I is. So we see it starts at 0 and goes to 9. So I'm going to erase everything again. And if we just take a look at if statements for a second here, if statements allow you to obviously make decisions in your code. So you want to see if something is true, so you say if this. So let's say in our case we had I as an integer. So if I just undo this and I leave this here, we say I. So now we can actually trace I should be equal to 10. So now here we could say if I is less than 20, and then we can run some code if that's true. So in this case, we can do a print line, and we could just say, yes, it is. It is less than 20. And we could see that that did run. When you use an if statement, it must evaluate some sort of Boolean situation. In other languages, you can say something like if 1, but you can't do that because it's not going to evaluate 1 to a Boolean. And of course, you can chain multiple ifs together. So if you were to do if I is less than 10, obviously that's not going to run. You can say else if I is less than 20, then that will run, and we'll do a print line on that. Yes, it is less than 20, so we'll get it is less than 20, and then we can do our else, which we don't need in this case. You also have switch statements. But you should note that the way that switch statements work in Swift is a little different than the way that switch statements work in other languages. In other languages, usually you have a switch statement, and which I'll write one right now, and we'll evaluate I because we already have it. And we'll do case, now I is going to be equal to 10 at this point. So we'll say if I is equal to 8, then we will do a print line, and we'll say it was 8. Now normally what you'd have to do here is you'd have to write break. But in Swift, it will automatically end as soon as it finds the case. But if we were to do case 10, we could do a print line. It was 10. And we can see that it's also giving us an error. It's saying that switch must be exhaustive. Because you don't normally have a break statement in here, you have to make sure that the switch includes all situations. So it could be 8, it could be 10, it could be other stuff, so we need to make sure we put a default in here in this situation. And we could say it was none of the above. Now you don't always have to do this because maybe you can include all of your possibilities, but a lot of times you will put a default statement in there because it's a lot to do that. It's a lot to do that, to put all your statements in there in a lot of cases. So in this case, it was 10. Now, one really, really cool feature is that you can actually evaluate more than one thing at a time. You could say, you could have another case up here that says, if it's 1, 2, or 3, then we'll do a print line, and we'll say it was low. And in the case of 10, we can say maybe it's 9 or 10, and we can say, yeah, it was 9 or 10 in this case. So you can actually do that. That's a really cool feature. Now, what does a break actually do? Once it hits that, it does go right to the end. And sometimes you'll need to do this because you cannot have empty cases. Now, here's one really cool feature I didn't mention earlier. When you're writing numbers, let's say you're going to have a count of 3 million. Now, it's really hard to write 3 million because you don't really know where you should stop. So what's even better is if you were to put something in here like an underscore. In Swift, you can do this, and it's like, yeah, that's totally fine with me. And it's just going to ignore those underscores. So if we just log the count there, let's put an equal sign to make this work. You'll see that it equals 3 million. So one really cool thing that you can do in switch statements also is you can check a range. So let's say we were to do a switch statement on that count of 3 million. So in this case, it's going to say it was none of the above, but let's say we wanted to just, in a silly case, we wanted to check if it's between 2 million and 4 million. And we need to write our print line. Now we can see that it was a number that was between 2 million and 4 million. So you can actually write ranges in those case statements. Another thing you can do in the switch statements that makes it really powerful is you can use that underscore. So let's say that we were evaluating what's called a tuple. Now you don't know what a tuple is yet, or maybe you do because you've seen it in other languages, but basically a tuple is written like this. Let's make a tuple called some point equal to 1, 1. Now that looks like a coordinate, and in this case we'll make it a coordinate. It's similar to an array in that it has a list of things, and I can explain more about that. Now you could say in this case we want to see if the case is where the tuple is equal to 0, 0. And in that case we'll say that, well, if it's 0, 0, it's at the origin of the map. Or what if it's between this? Now what does this mean? This means that it's anything and 0. Now it's still going on count here. Let's change this to some point. Okay. And we'll get rid of these. And so this means that it's anything 0, meaning it could be 1, 0, 2, 0, 3, 0, and it'll match it. Now what you can do that's even crazier is you can use a mixture of tuples and ranges. So let's say that it's anything from -2 to 2, and on the other side it's also -2 to 2. And in this case, we're going to print line, we got it. So in this case, it's 1, 1, and that 1 is between -2 and 2, and it's also between -2 and 2 on the x and the y. So you can actually write ranges and tuples together, and we have the 3 dots, so we know that it's an inclusive tuple. Now this gets even wackier and even more powerful, if you can believe it, because you can use constants, temporary constants, in the middle of your switch statements. So let's do another point, and this time we're going to make it 2, 0, okay? And we're going to switch on this sum point again. And this time we're going to say, well, let x and 0. And this basically means that we're going to pass in x into this sort of scope here, just like we had it in the for loops. We're passing x here, and that does mean that it's going to obviously accept it. So it's going to say, yes, it's at the origin, because we are accepting x, but we're setting a variable there, and we can say it's at the origin, and we can find out what x is. At the origin 2, so we know what x is in this case, which is really cool. Now, I don't know if I showed you this before, but this is a way of inserting variables into a string, which is much easier than concatenating strings, which you had to do before, where you have like hi, there. You know, obviously you don't need to do that now, because you can just kind of use this backslash parentheses thing to insert variables into strings. So to access those members in the tuple, you can use this dot syntax. So you can do some point dot 0, and that will print the first member of the tuple, and you can do some point dot 1, and that will grab the first, and this will grab the 0th element of that tuple. Now, what are we doing when we write x directly in here? This is called value binding. We're binding the values of these temporary constants, and those temporary constants you also saw in the for loop as well. The temporary constants are going to take on the value of part of or both of the values of the tuple, depending on what you use. So currently we're only using part of the value. If we were to write let y here, then we could do both as well. And now for the absolute power play, you have something called the where clause. So we have our point, which is 2, 0. And let's say let x equal x, let x. And we could say where x equals 2. So this is saying x is going to be passed in as a value binding, and we want it to at least be 0 where x equals 2, because we're not evaluating x, but we do want it to be passed in. So we can actually pass a where clause here. And you could also say where x is not equal to 2. So real quickly, in the loop, you've probably, if you've done programming before, you've seen a continue statement. So if you were to say if I equals 2, then continue, and then you could also do a print line here of I, and you'll see that it skips to 0, 1, 3. The only thing that happens is it just skips the instructions after it's been instructed to continue. Now, like I said before, switch statements don't work like your normal switch statements, where normally you have to write a break in C or in JavaScript, and this doesn't do that. But what if you wanted it to do that? So let's take an example where you have some point is 2, 0, and instead of these, we'll just make it a little simpler. We'll just say if it's 2.0, and the next one will be blank.0. So both of these should match. Now, here what it's going to say, let's just say it says at 2, 0. So it's going to match 2, 0. of course, and then it's not going to match the second one, even though the second one matches. But let's say we wanted the second one to match. All you have to do is you have to write fall through. And now, I mean, it was 8, doesn't make sense, but you can see, so we're at 2-0 again. In the console log, it matched both of them, and it did the fall through like a normal switch statement that you see in other programming languages. And now to kind of end this whole shebang, I'm going to show you how to label your switch statements and loops, which is useful. Now this loop, we're going to give it a label. We're going to call it main loop. And inside the loop, we're going to put this switch statement. And we'll put this constant above. And now we have it looping and then doing a switch in here. And we can label this switch as well to the main, let's call it the main switch. So now the question is, if I were to write break in here, which would it break? And what do we want it to break? So let's say that we want it to break the loop, but we don't have a good way of making it break the loop. Let's get rid of our fall through. And right here, we're at 2, and we want it to break. But it's not going to break the main loop. We want it to break the main loop. It's going to break the switch because that's the closest thing. So what we can do is we can say break main loop. And now you see what it did is it applied that break to the labeled loop, main loop and main switch. So if we were to change this to break main switch, then it's going to break the main switch and it's going to keep going every time, which doesn't really do anything. But if we wanted to stop the entire loop, we can stop the entire loop because we've labeled it. So that's kind of a quick introduction to loops. Okay, we're back here on the playground. We've scratched everything, we've erased everything. So arrays and dictionaries are coming up next. And if you've never heard of an array or a dictionary, I'm going to explain. So when you see an array in Swift, you'll notice it looks a little like an array in JavaScript, except that it wants to make sure that it knows exactly what elements are going inside, what type of elements are going inside. An array is a way that you store multiple values. Let's say you have a deck of cards and you want to store each card in the deck, and you have a deck that's called the card that's called the 5 of diamonds, and a card that's called the 3 of clubs, and you're going to store all these cards in the deck, and you want to be able to get to that deck, shuffle it, and all that stuff. Well, you could store all those cards in an array, and I'm going to show you how to make an array in Swift. Now here's a simple array, and this array is going to be made up of strings. So you can type var because it's going to be variable at some point. String array, let's just call it string array. And we can type string like we normally do. We're going to make a string. Except we'll type this open and close square bracket at the end. And we'll type equals. And then we can just initialize the creating of this array. This is similar to how you would do it in JavaScript, except obviously you don't type it, like you don't give it a type of string. And that's something similar you to see in Java. So we're going to have a string. The 3 elements in the string are going to be hello there, sir. And now if we were to just type string array, you could see hello there, sir is the name of the string, is the name of the array. You can add items to an array in a very cool fashion. So if you type string array plus equals, which means string array is equal to string array plus, and let's just add a string called how. So now we have an array you can see that says hello there, sir, how. And you can also use this awesomely similar to Python sort of way. You can do string array dot append, and the new element has to be a string, so we'll write how are. So now we have a string array that says hello there, sir, how are, and we could just append one more and say you. And if we trace this array, you'll see that it says hello there, sir, how are you? And you can press this little I button and it'll kind of inspect that array for you. And now if we want to insert an element into the array, we can type string array dot insert, and we can tell it exactly the name of the string, and we can tell it where we wanted to insert index, and that has to be an integer. So we'll say we'll put it at 0. This array was a sentence, but now it might not make as much sense. So now we have it's hello there, sir, how are you? So we inserted an element at 0, and then we printed it. The way that you loop through an array is using a for in loop, and that's very similar to a lot of other languages. So you could say for word in string array. The word is going to be the constant, so we can just print that word, and it will print everything in that array. If we press this plus button, we should be able to get to that console. Now we printed a string called word. Let's make this a little bigger. If we actually get the word, it says it's hello there, sir, and it's each on an individual line because it's looping through each element. So similarly to the insert, we can easily remove an element at a specific index. So if we were to do string array dot remove at index, and we tell it where we want it to remove it at, and we say 3, and that tells you what it actually removed. And if we were to print that string array, now you can ignore this for loop because it happened beforehand, but if we print it out now, we get it's hello there, how are you, because we took out sir, because we removed the one at index 3. Now I'll show you something super cool. We can do string array 1.3. Now we learned what the 1.3 is. That's a range. What we got there is 1, 2, and not including 3. So we got hello there back. So we can actually use a range to grab specific stuff. So if we wanted to add one more dot in there, we should get one more word out of that. So now you see hello there and how, because we got 1, 2, and 3. So this range 1 to 3 is inclusive. And now just to show you, we can use that range in a loop. We can say for num in 1 through 5, and then we can trace num, and you'll see that if we use a print line, that'll do 1, 2, 3, 4. And I had showed you that previously. Obviously, if you do one more dot, it'll do 1, 2, 3, 4, 5, just to go back. Anyway, back to arrays. What if we just want to grab an element from the array? How would you do that? Well, just like that. So we want to grab the element at index 2. It's going to be there because it's 0, 1, 2. That's very similar to a lot of other languages. And what if you want to remove the last item from the array? Now we did remove at index, but that has to count to index 3. You can actually do string array dot remove last, and then it won't count. So that's a little more efficient way of removing the last item if you need to remove the last item. Of course, there's no insert last because that's just appending to an array. There's no reason for that. Now, what if you want to loop through an array, but you want to know what index you're at? What you can do is you can say for index and value. So you want to grab the index and value while you're looping in, and then there's this global function called enumerate, and that will enumerate anything that's a sequence. So we're going to enumerate through the string array, and what we can do is we can print the index. We'll say that we are at this index plus 1 so that it makes it a little more understandable, and at this index is this, and we can do backslash, and we can say value. And you can see at 1 is this, it's. At 2 is this, hello. At 3, etc., etc., etc. So this is a special type of for in loop where instead of just grabbing one value and assigning it to that one value, you're assigning to two values at once. By using this global function enumerate, you're able to enumerate and get that index back. So there's more ways to create the array and initialize it with actual values. So we created an array before. Let's create an empty array. I'm going to show you something. We're going to make this array full of ints, and we're going to say it's an int array, and that's going to be equal to int. And we've just initialized an int array, and that needs to be capital I. Again, it's a little bit buggy. So if we were to trace some int, it's actually empty. So we initialized an empty array. And if we were to do .count, that will tell you how many elements are in the array. And if we were to do some int.append 3, it will append the number 3 to the array. And now we just have a number 3 in the array. And if we do count, it should say 1 because we only have one int in the array, and that is the number 3. And now that we have that array with the number 3 in it, we can actually empty it by saying some int and just assigning it to an empty array. And now you can see that it has 0 elements. And if we were to do some int.count, you'd see that it now has 0 elements. And you'll see that because this only takes ints, if we were to try and do some int.append and we were to try to write hi in there, you can see that it does not like that. It says that it cannot convert the expression to an int because it's not an int, it's a string. Now here's a situation where you want to pre-populate the array with a bunch of stuff that's all the same, and this is how you would do it. We're going to call this array 3 doubles, and we're just going to fill it with 3 doubles. And this time we're going to say fill it with how many? 3. Count 3. And we want a repeated value. So we want it to repeat the value of 3.14. So you can now see that there is an array that has 3 pies in it, 3.14. And now what if we made, that was 3 doubles, well we could call it, let's call it 3 pies. And what if we made one that's 3 taus, and we made that also a double, and we set the count to 3. Again, I'm getting a couple of errors because it's in beta. And we set the repeated, this is the same thing, value to 6.283. And now we have that. Now what if we wanted to combine the 2 arrays that we have? We wanted to concatenate them. Sometimes in some languages you need a method to do that, but in Swift you can just say 3 pies plus 3 taus. And you can see we have a new array that has those 2 combined. And obviously we could set that to another array. Now that is easy. So now that you're fairly beaten and bruised with arrays, let's talk about dictionaries, so we can erase everything. If you've never worked with a dictionary before, this is not a definition that I made up myself. A dictionary is a container that stores multiple values of the same type. So that already sounds just like an array. But unlike items in an array, items in a dictionary don't have a specified order. So you're thinking to yourself, why would you want that? Instead, you use a dictionary when you need to look up values based on their identifier, in kind of the same way that you look up a definition in a dictionary for a particular word. So that's what you would use a dictionary for. If you've used Objective-C dictionaries or C dictionaries, Swift is different in that Swift is specific about the types of keys and values it can store. That's different from Objective-C's NS Dictionary and Mutable Dictionary classes, because in those, you can use any kind of object as their keys and values, and you don't have to provide any information about the nature of these objects. In Swift, the types of keys and values that a dictionary can store is always made clear. And usually that's made explicitly clear, and I will show you how right now. So let's make a dictionary. So we'll make this dictionary of airports. You may have seen this example before. And we are going to set that. We need to set the keys and the values, what they're both going to be. So we're going to set that the keys and the values are both going to be strings. And let's make an airport EWR, which is Newark. And we'll make another key for JFK. We have one extra quote there. And we'll just write that the value is John F. Kennedy. And we'll make another one, which will just be, we'll just leave it at that for now. It's good enough. We need to tell Swift about the keys and the values of the dictionary. This might change later, so that's why we used a variable and not a constant. So that was one way to create that dictionary. Here's an even quicker way to write that entire dictionary. We can take out this part about it being a dictionary, and we can take out the part about it needing to be strings. Because the keys and the values are already strings, we can change that to Newark. It knows that what you put in there must be keys and values as strings. It can infer that from what you wrote. It kind of figured it out. So you can do the shortcut because Swift knows what you mean, because all the keys and all the values are strings. Let's do something with these dictionaries. Let's find out the number of items. Now we did that in arrays with the .count. What do you think it is in airports? Well, it's the same thing, .count. Let's add another airport to our list of airports, to our dictionary of airports. So right now we have airports. Let's add PHL, which is Philadelphia. So the key is going to be PHL, and the value is going to be Philadelphia. So now we have a new airport in there, and if we look at our airport again, we can see we now have JFK, PHL, and EWR, and they may not be in that order all the time. And we can also click this I next to it, and it gives you a quick synopsis. Now we were able to add the Philadelphia airport by using that square bracket syntax. There's another syntax you can use which uses a method instead, and that's using airports.updateValue. And we want to tell it the value that we want to update, which is it's backwards from what we just did. So this time we're going to change John F. Kennedy to just John F. Kennedy, let's say terminal. And the key that we want to update is JFK, which should already exist. Now an interesting thing to note is that when we used update value, this returns an optional, which you haven't learned about yet, but this is a great opportunity to talk about it. If we couldn't find what we were looking for in the update value function, then it would return nil. So it will either return the old value of the string we wanted to replace with, or it will return nil. This is called an optional string. It's written like this, with the question mark on the end. Now what can we use this for? So let's see what we can do. Let's create a constant updated value. It's equal to airports.updateValue. And in this time, we're going to update it with the space airport, which obviously does not exist. And the key, we're going to do SPC. So if we trace updated value, you'll see that it's nil because there was no space airport in our dictionary yet. But when we did update value for JFK, you can see that it returned a string John F. Kennedy because that is the old value before we changed that. That's what update value returns. It either returns nil or the value of the string, and that's called an optional. So now we can actually check, because the if statement needs a Boolean. It needs to be able to check. You can't just send it a string, so we can send it an optional. And we could say if updated value, and we'll know if when we went to do this, if it had found something. We can say print line, and we can say found it. Otherwise, we can say print line not found. And you can see that we hadn't found it because the space airport had not existed at that time. Now there's a shorter syntax you can use to do this whole if statement situation, and that is to define the constant within the if statement. So what we can do is we can remove our constant up here, and what we'll say is if, and we'll define the constant, let updated value equal airports dot update value, and this time we'll look for JFK Airport Terminal for key JFK. And what we did is we defined this constant here, and this update value is going to be available in this code block if it's found. Let me show you another thing. This is a quick way to remove an element from the dictionary. So we can say airports, and we know that we can access stuff by PHL just by their key like that, and we know what that does. We know that that grabs Philadelphia. If we just assign that to nil, then if we were to trace airports now, you'll see that Philadelphia is gone from that airport list. And if we comment this out, you'll see that Philadelphia is in there. So you can just assign to nil. Or you can use the method-based way of doing this. Again, there's always a lot of times there's a method available. So we can use airports dot remove or remove value for key, and we can tell it we want to remove PHL. And this time it will return what it removed. And again, this remove value for key is another optional because it may not find what you want it to remove, and you don't want it to throw an error. Instead, it's just going to return an optional, and that's going to be either nil or that key. So we can turn this into an if statement, and we can see if it was removed or not. So we can say if, and then we're going to create the constant removed value is equal to airport.removeValue, and that will return the optional. And then we can just print, hey, we actually removed this item, removed value. And it'll tell us over here that it removed Philadelphia, and we can say otherwise, because it's going to return, it's going to return false otherwise, we can print that it can't find it. And so it did remove Philadelphia, but if we tried to remove, instead of PHL, we tried to remove XYZ, you'll see that it's not found. So those optionals are really helpful, and it's pretty neat that you can define the constant within the if statement. And of course, you can always loop over dictionaries. If I just remove this if statement, you can write, use the same for in that you used for the arrays, except this time you're going to provide it with a key and value. So the key in this case is the airport code, so we'll just assign a constant temporarily, and we'll write airport code, and the other part is the airport. So we have the airport and the airport code, and we're going to loop through all the airports. And then we can do print line. We'll say, well, the airport code is this, and we'll grab that variable airport code, and the airport itself is this, airport. So now we get the airport code, which is the key, and the airport, which is the value. And we're just right now working with dictionaries that have strings as both the key and the value. It could be anything, they could be ints, whatever. Now I showed you how to empty an array. Emptying a dictionary is also very similar. So if you did airports in an array, we did this, just add a colon in the middle and it empties that dictionary. So if we did that, you can see that the dictionary is now empty. And if we want to, just two other little tricks, we can make an array of all the keys in the dictionary by doing airport.keys, and that you see returned all the keys of the dictionary. And we can do airport.values, and that will return back all the values. So one thing to note is that in Objective-C you used NS mutable and NS arrays, and the same thing with dictionaries, NS dictionaries and NS mutable dictionaries. To create a mutable and non-mutable array and dictionaries, it's a little easier in Swift because all you have to do, you already actually have all the tools you need at your fingertips. You have let and var, you have constants and variables. So if you use let, it's a constant and it'll make an immutable dictionary. If you assign it to a variable, then it makes it mutable and it can be changed. So to me that makes a whole lot of sense and it makes it a whole lot easier to do. And as you know, immutable collections are better for performance, so if you get the chance to use them, if you have that opportunity, then you should. We've covered a lot of material up to this point, and yet there's still a lot of material to cover. In part 2, we will resume with functions. See you then.